This RC car was completely built by me, from the mechanical part to the control system. In this video, I'll show how I built it, the problem I ran into, and what I would do differently if I started the project again. I wanted to build a practical project related to my field, embedded and electronics programming. I also had access to a 3D printer and wanted to create something physical with my own hands. More complex projects like quadcopters or other flying devices require much more time and experience. So I decided to start with a simpler but fully completed idea, an RC car. The brain of the car is an Arduino Nano. Control is handled through infrared communication. Commands are sent from a remote controller. The infrared receiver on the car detects the signal, after which the Arduino decodes it and controls the motors. Servo motors are used for movement. The wheels were purchased, while the body and some mechanical parts were 3D printed by me. The control logic is very simple. The remote has arrow buttons. Pressing a button sets the corresponding direction. To stop the car, the OK button is used. During development, I faced serious challenges, especially with the steering system. I was too focused on the steering mechanism itself and didn't account for the fact that some parts of the body would physically block the wheel from turning. At that point, the body was already printed and the car was already moving. For me, that was an achievement. So, I consciously decided not to redesign the project, but to accept this limitation and finish it. You can also notice some 3D printing defects on parts of the body. Additionally, due to soldering difficulties, I abandoned my initial idea of soldering all components directly onto the body. This project taught me several important lessons. First, my compact remote controller emits a fairly weak signal. For more serious projects, more reliable communication systems are needed or alternatives to infrared control. Second, I significantly improved my 3D modeling skills. I learned how to design parts that are difficult to print without supports and how to understand the causes of printing defects. And third, I clearly realized the importance of choosing the right project complexity and knowing when to stop. A finished project provides more experience than a perfect but unfinished one. If I were to build a second version of this project, I would pay much more attention to mechanical design, especially the placement of moving parts and the areas around them. I would also replace infrared communication with a more stable option such as Bluetooth. In addition, I would design my own PCB using tools like Altium Circuit Maker and order it for manufacturing to avoid soldering related issues. If you are just getting started, don't be afraid of simple projects. One finished project gives more knowledge and confidence than a dozen unfinished ideas. Thank you for watching and for supporting this video.